Hello, and in this video, I would like to do a little introduction to the chain rule in reverse, because I know from experience that students find it really difficult to spot when it is appropriate to use the chain rule in reverse. So there's lots of different ways of thinking about the chain rule in reverse, different ways it's taught. One of the principal ways that it's taught is by doing inspection and kind of like reversing the process and thinking about what would an original function have been that could differentiate to give us the one that we're trying to integrate, which is absolutely fine. I, however, like to physically do the chain rule backwards by identifying the different parts of a question, identifying what is the outer, which bit is the inner, and which bit is the derivative, and then literally doing the opposite of the chain rule. So what do I mean by that? So let's say, for example, let's have a look at an example, a nice straightforward example, cos x sin² x. Okay, we're integrating that with respect to x. So it takes a little while to get used to this, but I like to start off by identifying which bit would I consider to be the outer function, which bit would I consider to be the inner, and which bit would I consider to be the derivative. Okay, so I'm going to rewrite this as cos x sin² x. Now, in this case, I think the outer is the something squared. The inner is the sin x. And the derivative of sine is cos. Now, the chain rule backwards is literally doing the opposite of what we do in the chain rule. So what I'm going to be doing is I'm going to be integrating the outer function and dividing by the derivative of the inner function, which is the reverse of what we do in the chain rule. So if I integrate the outer function, something squared is going to integrate into something cubed divided by 3. So I write down raise the power by 1 and divide by the new power. So I go raise the power by 1, divide by the new power. And then I've still got my cos there. So I've integrated the outer function, and I'm now going to divide by the derivative of the inner function. So as the cos cancels, and my answer is 1/3 sin x³ add c, and that's my answer. Okay, so that's one straightforward example. Let's look at another one. Let's imagine that we had x times by x² add 4, x² add 4, and let's say this whole thing is cubed, and let's say we've got a 2 there. Okay, so in this one, I would say my outer, my inner, my derivative. My outer is something cubed. My inner is x² add 4. The derivative of my inner is 2x. So I'm going to integrate my outer function. So that's going to go to something to the power of 4 divided by 4. I've still got my 2x there, but then I divide by the derivative of the inner function. So that 2x cancels out, and my answer is in fact 1/4 x² add 4 all to the power of 4 add c. Okay, so that's example 2 and that's example 1. So that's 2 examples of how I would think about it. Identify the outer, the inner, and the derivative. Okay, let's have a look at, there's a few questions here. Let me just have a quick look at some of these and think about how we might possibly do these. So let's think about this first one. So in this one here, A, we have got 2x add 1, and this whole thing is x² add x add 1 to the power 4 dx. So I'm going to be integrating that. So I need to integrate the outer and divide by the derivative of the inner. So here I'm going to write down OID. My outer is something to the power 4. My inner is x² add x add 1. My derivative is 2x add 1. I'm going to integrate the outer. I'm going to divide by the derivative of the inner. So that's going to go to something to the power 4. It's going to go to something to the power 5 over 5. So, and the something happens to be x² add x add 1. I've still got my 2x add 1 there. And then I divide by the derivative of the inner, which is 2x add 1 in this case. So that cancels, and my answer is 1/5 x squared add x add 1 all to the power 5 add c. Okay, so that's that is that one, how we do A. Let's have a look at another one. Let's look at C. I'm just picking a random selection of these example questions here. So in this one, C, we have got sine to the power 5, 3x, cos 3x, dx. I'm going to have my outer, my inner, and my derivative. Now, in this case, my outer is something to the power 5. My inner function is sine of 3x. The derivative of sine 3x is cos 3x. But remember, I need to use the chain rule to multiply by the derivative of the inner function, okay? So the derivative of sine 3x is actually 3 cos 3x. So I'm going to integrate the outer function, raise the power by 1 and divide by the new power. So that's going to go to 1/6 sine of 3x all to the power of 6. Because the power, this could be rewritten, by the way, as sine 3x to the power 5, like that. Okay, so that's another way of writing that. So I've raised the power by 1 divided by the new power. So I've integrated the outer function. I've got here my cos 3x. I'm going to divide by the derivative of that. So that is 3 cos 3x. So that cos cancels, and that goes to 1/18. 1/18 sine to the sine, 3x to the power 6. So sine of 3x all to the power of 6 add c. And that is that one integrated. Okay, let's do another one while we're on this little practicing. Let's do D. Okay, so we have got cos x, and we've got e to the power of sine x. Okay, we're integrating that. So here, my outer is e to the something. My inner is sine x. The derivative of sine x is cos x. So I'm going to integrate the outer function and divide by the derivative of the inner function. So when you integrate e to the something, it basically stays the same because that's part of how it was defined in the first place. So the integral of e to the something stays as e to the something. I've got my cos x there, so I've integrated the outer. I'm now going to divide by the derivative of the inner, which is the cos x. So that goes, so my answer is just, in this case, e to the sine x add c. Okay, let me just make up another example of that one just to help you understand. Let's imagine I wanted to integrate x squared e to the x cubed dx. Okay, again, in my experience, this is one that students fail to recognize as being chain rule in reverse. Outer, inner derivative. Outer is e to the something. The inner is x cubed. The derivative of x cubed is 3x squared. When I integrate the outer function and divide by the derivative of the inner, so the integral of e to the something is e to the something. It just stays the same. So you just write it down with its power as it was. That's that integrated. I've still got my x squared there, and I now divide by the derivative of the inner function, which is 3x squared. That cancels. So my answer is 1/3 e to the x cubed add c. And that's the example of how I would integrate x squared e to the x cubed. Let's do another one. Let's do e. Okay, e, here we go. The integral of 3e to the 2x over e to the 2x add 3 all squared dx. Okay, so I'm going to have my outer, my inner, and my derivative. So my outer in this case is something to the power of -2. My inner is the e⁴ add 3. The derivative of e⁴ add 3 is e⁴x, but I must remember to times by the derivative of the inner function. So it's actually e⁴x times by 2. To help me recognize what to do here, I'm going to rewrite this as e⁴x add 3 to the -2, which I think makes it easier to deal with conceptually. So to integrate that and divide by that, I raise the power by 1 and divide by the new power. So that's going to go to e⁴x add 3 to the -1 divided by -1. So I've integrated my outer function, and I'm now going to divide by the derivative of the inner function, which is 2e to the 2x. So that cancels, and in this case, I'm going to get -3/2 e⁴x add 3 all to the -1 add c, which could be written as -3/2 e⁴x add 3 add c, like that. Okay, so that would be that one done. And that's just like a little brief introduction. I will be producing further videos where I go into that in a lot more detail. But that was just like a quick video just to give you an alternative approach for how to deal with the chain rule in reverse. And as I say, it depends on looking for the outer function, the inner function, and considering which bit is which bit's the outer and which bit's the inner. Okay. In subsequent videos, I will be going through some more of these and looking at integration techniques in general. I hope that you found that helpful, and I will see you in the next video.